Hi students, this is El-Refaei math teacher for both AS and A2 level. Today we're going to start with the chapter 3 trigonometry. In the beginning, I'm going to review the 3 trigonometric ratios we learned in O-level. Going back to the right angle triangle, I have the angle theta, y is the opposite, and x adjacent, r hypotenuse. And do you remember with the Pythagorean theorem, x squared plus y squared equals r squared. And we know that sine theta, it's opposite over hypotenuse, y over r. Cosine theta, adjacent over hypotenuse, x over r. Tan theta, it's opposite over adjacent, or it's sine theta over cosine theta. But actually, we don't have 3 trigonometric ratios. We have 6 trigonometric ratios. Let's find out the other 3 trigonometric ratios. If I flipped opposite over adjacent over hypotenuse to be hypotenuse over adjacent over opposite, I'm going to get something we call it cosecant. If I flip adjacent over hypotenuse, I'm going to get something we call it secant. And if I flipped adjacent over opposite, or cosine theta over sine theta, or 1 over tan theta, I'm going to get something we call it cotangent, or cot. So, what is cosecant? It's hypotenuse over opposite, or 1 over sine theta. What is cosecant? Hypotenuse over adjacent, or 1 over cosine theta. Cot theta, 1 over tan. I hope these 6 ratios are clear, students. During the AS level, we took an identity, which is sine square theta plus cosine square theta equals 1. Sine square theta plus cosine square theta equals 1. And we learned that this identity came from Pythagorean's theorem. X squared plus y squared equals r squared. If I divided each term by r squared, r squared, r squared, so x over r, all of them squared, plus y over r, all of them squared, equals 1. X over r will give me cosine squared, y over r squared will give me cosine squared, and sine squared plus cosine squared equals 1. This identity will give me another 2 identities. Sine squared theta equals 1 minus cosine squared theta. Also, cosine squared theta equals 1 minus sine squared theta. And because we have 6 ratios, I'm going to have another identities. Let's find these identities. First of all, I'm going back to the main identity we learned during AS, sine squared theta plus cosine squared theta equals 1. I'm going to divide each term by sine squared. So divided by sine squared theta over sine squared theta over sine squared theta. Sine squared over sine squared equals 1 plus cosine theta over sine theta, all of them squared, equals 1 over sine squared theta, sine theta, all of them squared. Cosine over sine, it will be cot. So 1 plus cot squared theta equal 1 over sine. As we know, it's cosecant theta squared. So 1 plus cot squared equals cosecant squared. I'm going to get another two identities from this identity. 1 equals cosecant squared theta minus cot squared theta, or cot squared theta equals cosecant squared theta minus 1. Let's go back to the sine squared plus cosine squared equals 1. Sine squared theta plus cosine squared theta equals 1. I'm going to divide each term by cosine squared. Cosine squared theta over cosine squared theta over cosine squared theta. So sine theta over cosine theta, all of it squared, plus 1 equals 1 over cos theta, all of them squared. Sine over cosine, it will be tan. So tan squared theta plus 1 equals 1 over cosine. It's secant squared theta. Cot squared plus 1 equals secant squared. I'm going to get another two identities from this identity. 1 equals secant squared theta minus tan squared theta, or tan squared theta equals secant squared theta minus 1. Okay, let's move to sketch cosecant, secant, and cotangent. Okay, in order to sketch cosecant theta, I'm going to review sketching sine theta, and I'm going to use a limited domain, or restricted domain, where theta is more than or equal 0, less than or equal 360. 0, 90, 180, 270, and 360. Sine 0, 0, sine 91, sine 180, 0, sine 270, negative 1, sine 360, 0. Let's sketch it. 1, negative 1, the range for the sine from 1 to negative 1. I have 90, 180, 270, 360. Maximum, minimum. Okay. Let's move to the cosecant. What is cosecant? Is 1 over sine theta. So I'm going to use the same angle sizes, 0, 90, 180, 270, and 360. As you know, sine 0 is 0, but I have to flip it in order to get cosecant. So 0 over 1, flip it, 1 over 0, it will give me math error. And in this case, I will have asymptote line. Continue. 1, 1 over 1, it will be 1. 0 over 1, flip it to get cosecant. Also, it will be math error or asymptote. Negative 1 over 1, flip it, it will be also negative 1. And 0 over 1, 1 over 0, it will be also asymptote. So I have 3 asymptote line, 0, 180, 360. I'm going to use a different color. I will have asymptote on 0, another asymptote, 180, another asymptote, 360. And then I have to flip it between 0 and 180, and I have to be careful about the asymptote line. Same between 180 and 360. So I have here this point, 91, 270, negative 1. The blue sketching is for sine theta. The red sketching is for cosecant theta. Okay. If you look carefully to the cosecant, which is the red sketching, it will be periodic every 360. And I'm going to continue the same sketch. Okay? It will be periodic every 360. The domain x belongs to R. If I didn't give you a restricted domain, the domain will be also x belongs to R, or theta belongs to R, but I have to be careful. Theta should not be 0, 180, 360, and so on, because I have asymptote lines at these points. This is for the domain. By the range, y is more than or equal 1, or y is less than or equal negative 1. I don't have a range for the cosecant between negative 1 and 1. I hope sketching for the cosecant understood. If you have any question, you can write it on the comment. Let's move to the secant. I'm going to use the same steps. As you know, secant is 1 over cosine theta. So I have to sketch cosine theta first. I'm going to use a restricted domain from theta more than or equal 0, less than or equal to pi. I'm going to use theta as an in-the-pi form. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Cos 0 is 1, cos pi over 2, 0, cos pi negative 1, cos 3 pi over 2, 0, cos 2 pi, 1. I'm going to sketch it. Also, the range for the cos between negative 1 and 1. Pi over 2, pi, 3 pi over 2, 2 pi. Okay. Then I'm going to sketch secant. As you know, as I said before, secant is 1 over cosine. 0, pi over 2, pi, 3 pi over 2, 2 pi. One over 1, it will be 1. 0 over 1, it will give me asymptote line. Negative 1 over 1, negative 1. 0 over 1, you flip it. 1 over 0, asymptote line. 1 over 1, it will be 1. So I will have asymptote at pi over 2 and 3 pi over 2. And then I have to flip the graphs. I have a intersection point here. Be careful about the asymptote. For secant, the domain, if I didn't give you a restricted one, the domain always theta belongs to R, but theta should not be equal. Pi over 2, 3 pi over 2, and so on, the odd multiple for pi over 2, the odd multiple for pi over 2. So the secant asymptote, it will be 5 over 2 and this 7 over 2. The range y is more than or equal 1, or y is less than or equal negative 1. The blue sketching for cos, the red sketching for secant. The last sketching, it will be for cot. But in order to sketch cot theta, I'm going to use cos theta over sine theta. I'm not going to use 1 over tan. No, cos theta over sine theta. And I'm going to use restricted domain where theta is more than or equal 0, less than or equal 2 pi. 0, pi over 2, pi, 3 pi over 2, 2 pi. I'm going to revise the unit circle. Unit circle, it's a circle with 1 unit length. This circle intersects xy axis at 4 major points: 1, 0, 0, 1, -1, 0, and 0, -1. And as you know, the x-axis represents cosine theta, y-axis represents sine theta. According to the unit circle, theta equals 0. I'm going to divide 0 over 1, or 1 over 0. It's cosine over sine, so I have to divide it 1 over 0. 1 over 0, it gives me math error. And I said before, math error means asymptote line. Pi over 2, 0 over 1. Pi, -1 over 0, asymptote line. 3 pi over 2, 0 over -1, which is 0, 2 pi, asymptote line. So I have 3 asymptote lines, 0, pi, and 2 pi. Okay, I have pi over 2, pi, 3 pi over 2, 2 pi, and I have asymptote at 0, pi, and pi over 2. I think you remember how you sketch this tan theta. Tan theta, it had asymptote lines at pi over 2 and 3 pi over 2. And it was upgoing graph. Upgoing graph. Now, because I'm talking about cut, it's downgoing graph. And it will intersect the x-axis at pi over 2 and 3 pi over 2. At pi over 2 and the 3 pi over 2. Okay. The domain, if I didn't give you a restricted domain, theta belongs to R, where theta should not be equal 0, pi, 2 pi, and so on. So at 3 pi, I would have asymptote line. At 4 pi, I would have another asymptote line. So every pi, I would have an asymptote line, and it's periodic in every pi. The range y belongs to R. I hope sketching sine, cosecant, cos, secant, and cotangent graphs clear. If you have any questions, please send me on the comments, share and subscribe. Don't forget to solve more questions from your book, and if you have classified, solve them. I finished part A for lesson 3.1. See you at part B for the lesson 3.1. See you then.